Have you heard of symmetrical shapes? A shape or a figure is said to be symmetrical if one half of it is a mirror image of the other half. Let's do a paper exercise. When we fold a circular piece of paper about its diameter, we get two semicircles. Did you find anything interesting here? Yes, these semicircles are exact replicas of each other. What does this mean? This shows that a circle is symmetrical about its diameter. Mathematically, a figure is said to be symmetrical if there is a line in the plane of the figure which divides the figure into two identical parts such that the two parts cover each other exactly. This line is called the axis of symmetry or the line of symmetry of the figure. And interestingly, a symmetrical figure may have more than one axis of symmetry. Back to the real world. What are you doing, Snail?
I am studying the lines of symmetry it has.
Okay, for that you don't have to pop your eyes out like that. Drop it and come here. I'll show you some other symmetrical figures.
Miss Marks, this was a gift from my friend and it's now in two pieces. And I am so sad.
Oh, okay.
No, let me dedicate a song to it. Oh dear picture, I miss you.
Snail, this session is about math. So focus on math now.
But I was talking about the symmetry which we study in math.
Yes, but we need to see some other examples apart from your torn picture. So let's go to the virtual world to see some more figures and their line of symmetry. Consider an equilateral triangle. Can you guess if it has any line of symmetry or not? A simple test to determine if a given figure has a line of symmetry or not is to fold the figure along the supposed line of symmetry and check if the two halves of the figure coincides. Here we can see that the two halves of the equilateral triangle coincide along the three lines. Thus, an equilateral triangle has three lines of symmetry. In the figure, lines of symmetry lies along the angle bisectors and the perpendicular bisectors of the three sides of the triangle. Now consider a square. If you fold the square along its diagonals as shown on the screen, you will find that the two halves of the square exactly fit over each other. Also, on folding the square in two halves vertically or horizontally, we will observe that the two halves overlap each other. Thus, a square has four lines of symmetry.
Wow! There is so much symmetry in geometrical shapes.
That's very true, Snail. But you know, symmetry is not confined only to geometrical shapes, but numbers and alphabets also have symmetry.
Really?
Yes. Now look at this chart closely and tell me which of these numbers have line symmetry?
Another test. I hate tests.
Oh, it's so easy, Snail. Come on. Think fast. Think like a super comp.
Oh yes, I know.
Good. Then tell me.
It's 1, 3 and 8. Yes.
Right. Now look again. Aren't you missing any number?
No.
Oh, you missed 0. See? It has infinite lines of symmetry.
Oh yes. I thought that is too obvious. You should be knowing it.
Snail, Snail will be snail always. Anyways, time to go to the virtual world now. Let's consider a regular pentagon. We can fold this pentagon along 5 lines such that the 2 halves formed by each line coincide with each other. Thus, a regular pentagon has 5 lines of symmetry. These 5 lines represent the angle bisectors and the perpendicular bisectors of its sides. Next, let's take up a regular hexagon. On folding it along its 3 diagonals, we observed that the 2 halves fit exactly one over the other. Also, if it is folded along the lines joining the midpoints of its opposite sides, the 2 halves fit exactly over each other. Thus, we obtain 6 lines of symmetry for a regular hexagon, of which 3 lines are along its diagonals and other 3 are central lines. Consider a circle. When you fold a circle along any of its diameters, its 2 halves overlap each other. Since a circle has infinite number of diameters, so it has infinite lines of symmetry.